Hi, today we are doing the hardest paper of the AS module, Further Peer 1. This qualification is for OCR MEI, so if you're not doing this, I will turn away and look for some other guides. But if you're doing this, you'll need an answer booklet which will be given. You can use line paper if you want to follow through this paper with me. Some graph paper for graph work, and an MEI examination formula and table, and that will be given to you as well. So let us start. And this paper, like all paper, is out of 72, and usually the grade boundary of this paper will be quite low because it is a tough paper. For this, because it's FP1 and the information within is very dense, I will try to explain them thoroughly, and so I will split the video in two: section A as part 1 and section B as part 2. So if you want to follow through the entire paper, then you can look at both. So now on to question 1. You're given that matrix A 2, -1, 0, 3, and matrix B 3, 1, -2, 4. You have to find BA. And remember, matrix multiplication is not commutative, so you can't do AB. You have to do BA. Well, that's what we need to do right now. So we've got a 3, 1, -2, 4. And that multiplied by a 2, -1, 0, 3. Okay, so now we've got these two. Fairly typical matrix question on an FP1 paper. Sometimes its matrix can come out as a trick, as a lot of people can't do 3x3 matrix, but sometimes they'll throw one out just to trip you or something like that. So to do BA, you need to do the normal matrix multiplication. So the first term will be 3 times 2 and plus 1 times 0, which is 0. Then you've got the other term on the right, 3 times -1 plus 1 times 3, so that is 3. On the bottom, we use -2 and 4 to 2 and 0, which you get -2 times 2 plus 0, because again it's 0. And so now the last one will be -2 times -1, then plus 4 times 3. So you have to simplify the whole thing in order for it to be counted as correct. So 3 times 2 is 6, plus 0 is 6. -1 times 3 plus 3 is 0, because it's -3 plus 3. -2 times 2 plus 0 is -4. And the last one will be -1 times -2, which is 2, plus 4 times 3, 12, so it's 14. And so the first question answer is 6, 0, -4, 14. Okay, so this is part 1. Now part 2, a plane shape error 3, transform using matrix A. Matrix, the image is transformed using B. So essentially, you have transformed a shape by A, then B, which is this equivalent of transforming with BA. And so now we need to find the area. And if your teacher have told you in lesson a determinant of a matrix refer to the area multiplier of that shape. So in this case, we will find the determinant of BA. Then we multiply that by 3 to get our new area. So now the determinant of this matrix is 6 times 14 minus -4 times 0, which is 0. So the answer is 6 times 14, which is 84. A bit of mental math. That gives us 84 as our matrix multiplier. Now we need to multiply the base area, which is 3, by 84, and that would give us 252 as the final area of the shape that has been transformed. Okay, so on to question 2. You're given that alpha is -3 plus 4j. Calculate alpha squared. This is some of the more typical questions on imaginary. Nope, it's 3 plus 4j. I got the signs messed up, which is typical. Now alpha square means we need to square this imaginary number, and if you square an imaginary number, you get another imaginary number. Okay, so we do the good old basic of expansion of brackets, and this will yield you a 9. Actually, you don't need to do this, do you? You know how basic quadratic works. The basic formula a plus b bracket squared is equal to a squared plus 2ab plus b squared. So we can do -3 squared plus 2 times -3 times 4j, and we add another 4j squared. Not inside the bracket, but outside the bracket. Okay, so we now have this equation, and we need to simplify this. The first term is 9, as I have demonstrated a bit before. So now we do the imaginary bit, which is 2 times 3 times 4, which is 4 factorial. That is 24. It's negative because there's only one negative sign on the -3. And remember, you need to add the j on. You add another 4 times 4, which is 16. But remember, you've got a j squared, which is -1. And therefore, you'll get the answer as 9 minus 16, which is -7 minus 24j. That will be our answer to the first part of the question. Now, second part, express alpha in modulus argument form. One of the most fundamental part of of using imaginary number is to use Argand diagram. I will have to use my own calculator. Remember to set your angle calculation to radian form, because modulus argument only works when you use radians. So first of all, let's us find the modulus of minus 3 plus 4j. The modulus, basically you can do a basic Argand diagram, which is somewhere like this. A negative 3 plus 4 will be around here. As much as this doesn't look like it, it is minus 3 plus 4. This is the imaginary axis, this is the real axis. I don't know why they changed to J not long ago, but I prefer I. Okay, so essentially you want to find the length from the origin to the point, and we know that the height of this is 4 because by definition plus 4j equals go up by 4. Minus 3 means go left by 3, and so now we've got a right angled triangle because these two axes are perpendicular to each other. And to find the modulus, you just need to do a simple and basic Pythagoras rule, which is not 2 squared, it's 3 squared plus 4 squared will be equal to the modulus of alpha squared. I'm not sure how do I type alpha, but I'll just type A, I guess. Alpha squared. This is the modulus, and so this 3, 4 reminds you with a very typical right angled triangle, as well as it's called the Pythagorean triangle. The most simple one is 3, 4, and 5. So the answer to alpha is mod alpha is equal to 5. Okay, so we've got part, half of the part done. Now we need to find the argument of this. And remember, all angle from a Argand diagram goes from the x-axis anti-clockwise to the angle. So this is the angle we want to find. The thing is, we can only find this angle, so we need to do a essentially 180 degree minus that angle. But the problem is we're using radian instead, so 360 degree is actually 2 pi, and I forgot how to write pi, so I'll just pi. Right, so we've got 2 pi as one circle, and we know that half a circle will be equal to pi, so the answer will be pi minus the angle that we can calculate. And how do we calculate this angle? Well, simple basic trigonometry. If you're doing this paper, you should be able to do basic trigonometry. If not, please reconsider not doing this paper because you won't be able to do it. So you do arctangent of 4 over 3, and you will get 0.92725, and that is in radian. So we do a pi, subtract that, and you get 2.214 radians, and you can write that in 3 significant figure, and you won't be penalized for giving some inaccurate answer. So the angle is 2.21 radians, but the question actually asks you not to find the argument and the modulus. He wants you to put alpha as modulus argument form, which means you need to do the mod of alpha multiplied by cos of the arc plus j sine argument. And now you just substitute the value in, and you get that 5 times cosine of 2.21 plus j sine 2.21. That is the final answer for this question. Okay, now we're done with 2 questions, now 3. Show that set 3 is a root of the cubic equation and find other roots. So how do you find that a certain number is a root of a cubic number? Well, you use factor theorem. It's a very basic rule that you should always apply when you have a real number as root. So let's substitute 3 into that and see what comes as 0. Well, will it comes to 0? And spoiler alert, it will. Well, first remove this wonderful contraption. Okay, we've got a 3. Well, z equals to 3, so the root will be oh wait, no, it gave you z equals 3, so you just substitute z as 3. If it gave you that z minus 3 is 0, then you put that z is 3. So it's a bit tricky about how the signs work. Just you will have to understand how the thing work before you actually sit the exam. This is a 3 cubed plus 3 squared minus 7 times 3, then minus 15, and that will give you 27 plus 9 minus 21 minus 15, and if you add up both the positive number together, you get 36. If you add both negative number together, you again get 36, and so it equals to 0. And because of factor theorem, 3 is a root. So that's one part, and find the other roots. Now we need to find roots. The only way to find a root is basically you factorize it into a quadratic, then you factorize the quadratic again. So what you need to do is to do a straight vertical division by some very annoying method. I am not sure if you can save more time by doing anything else, but this is definitely the right way if you are doing an exam. Remember, this time we're using z minus 3 because we want this to be 0, because we know that this whole thing is 0. So this factor will make this whole equation 0, and yeah, basically. So now this we need to match the first term as z squared, so that this is z cubed minus 3. So here we have another minus 3 z. Okay, I pressed the wrong number. Z squared. Now you do the first minus the other, so you get actually 4z squared. Then you have another minus 7. And now up here you need to do a plus 4. Okay, I can't type. Okay, you do another plus 4, because you have a plus 4, you multiply that and you get 4z squared, and the other term will be 4 times 3, which is negative 12z instead. So now you do another subtraction. 7 minus negative 12 is 5, and you have a minus 15 that carried forward from up there, and the last thing you want is 5, and it's a plus 5. So now you have factorized this thing into a quadratic that looks like this. So you can write down that cubic as z minus 3 times z squared plus 4z plus 5, and this will be equal to 0. And now you need to factorize this term in order to get the answer of this question, the other two roots. But the thing about here is that there's no valid way of factorizing this equation, so we must use quadratic equation. So quadratic equation, minus 4 plus or minus, and I can't take that sign again, the root of b squared, which is 16, minus 4 times 5 times 1 is 20, and here we have an imaginary number. So if you plot the graph, this cubic only crossed the x-axis once at z equals 3. The other two won't touch. And all over 2a, which is 1, so 2 times 1 is 2. Right, okay, so now we need to simplify this. To simplify this, it's quite simple. Root of 16 minus 20 is the root of negative 4. And as we know, we can turn that into the root of 4 times I, or j. Because two roots can multiply together, and the content within will be multiplied. So this is root of negative 1 times 4 is root of negative 4. Now we have root 4, which is 2, so we have got 2j right here. So the answer to this, because we divide the whole thing by 2, we do minus 4 divided by 2, which is minus 2. Then we have a plus 2j over 2 is just j, so the answer is minus 2 plus j, and minus 2 minus j, because this is a plus or minus sign. Nearly forgot about that. If I can select the correct tool, yeah. Okay, so these two are the answer to this question. Now show the roots on an Argand diagram. Another typical question, and now we will use the graph paper that you have, which I do not have. Well, I do have graph paper beside me, but I can't use it on the computer. So what we need to do is to mark that we have z equals 3 is a root, so it definitely is about here, and we have the two answer which I've written down, minus 2 plus j, which is minus 2 plus j right here, and minus 2 minus j right here. So remember to label your axis. This is minus 1, this is plus 1, this is 3, this is 2, negative 2, and label this is axis j, x is real, if I can actually write, which I can't. Right, so this is it for this question really. Imaginary are typically quite simple. Now, a very annoying type of question includes show that phrase. This phrase means every single step must be written, and if you don't, you risk losing marks. So in this case, you want to use the standard formula of sum of r and sum of r squared to show that this equation is equal to this beast. So first of all, let's evaluate the inner part, r plus 1, r minus 2. R plus 1, r minus 2. Okay, now we have this number, and we expand the bracket to get r squared minus 2r, minus r plus minus 2. I can't do math today for some reason, so okay. Now we've got this thing, and remember you need to bracket the thing before you do the sum of sign. And again, on the computer, all I can do is this. This actually looks disgustingly bad, so I will try to fix that. That looks a bit better. And this is n. And you can actually factor in that sum into every single term. So basically this would become the sum of r squared minus the sum of r minus the sum of 2. And now we have a standard formula, and some random number, the sum of 2. What is the sum of 2? Well, because there are n number of 2's, you can say that there are 2n amount of value right here. So this is actually a negative 2n. Now evaluate these two. The sum of r squared is a sixth of n times n plus 1 times 2n plus 1. You can find this in your formula book, so you don't need to actually do a lot to find it. Then sum of r, this one you have to remember because it is not in the book. This is just half of n times n plus 1. Alright, now we have this big thing. The first thing you need to do is to factorize some factors out. This particular fraction is not helpful at all, and so we need to factor this out. And as you can see, you have an n on every single one of them, so why not take the n out? Remember to put a bracket so that you didn't look at it as like 1 over 6n or something. Okay, so now we have factorized a sixth of n, so we have another big thing, and I'll use a square bracket actually. So without a sixth n, this first term will become n plus 1 2n plus 1, and the second term will become well, a half divided by a sixth, if you can do math, is 3. Hopefully. I need to verify because I can't do math. Yes, it is 3. You have removed the n, so that's 3 times 3 times n plus 1. And the last term will be minus 2 divided by 1/6, which is 12. N was taken out, so you don't need to include that. So this is the whole thing. Now, I'm not going to copy the first term because we know this is as it is, and I won't touch it. So now let us fix the inner part of this massive equation. And n plus 1 times 2n plus 1, you have to expand that thing to get to n squared plus 3n plus 1, then minus 3n plus 3 minus 12. This is the entire thing expanded, and now you try to factorize everything. So you get 2n squared plus 3n minus 3n, which is 0. So we are just looking at the constant term, which is 1 plus 3 minus 12, which is 4 minus 12. Okay, it's 8. It's minus 8. Well, okay, excuse myself. I forgot that this is a negative 3. So it should be a negative, not a 33. It's a negative 3. So actually this is negative 15 plus 1, which is negative 14. Not negative 14. And now here you can actually factorize out another 2 to get 2n squared minus 7. And so after you factor out 2, you multiply that with 1/6 to get 1/3 times n times n squared minus 7. And this is the answer that they want. So you have to do all the steps, every single one of them. And I will not say that this is every single step because I think I skipped a few, like n times 2n is 2n squared, n times 1 is n plus 2n, n plus 1. And I've sped up this step by 1 because I'm making a video, but try to do every single step out in the exam. It will not harm you. Okay, so we've got this question covered. Now question 5, equation x cubed plus px squared plus qx plus r has root alpha, beta, gamma, and it gave you all the stuff. And now we need to find the value of p and r. So p is a term b, so we know this term is equal to, it's related to the root, and it's related to this number, and alpha plus beta plus gamma is equal to negative b over a is 1, and negative b is negative p, so negative p will be equal to 3, and so p will be equal to negative 3. I hope that is clear enough. I'm not gonna actually write anything down for this one because it's quite trivial. It's just 2 marks for each. And r is the multiple of every one of them, and this is term A, B, C, D, and again, because it's a D, you need to do negative D over A. And so negative D over A is this, and so R will be equal to negative R will be equal to negative 7, which means R is 7. So that's part 1 right here. Part 2, find the value of Q. Now this is a bit more tricky because all you have is alpha squared, beta squared, gamma squared, and what you want is alpha beta plus beta gamma plus alpha gamma. How do you get that? Well, if you are smart about algebra, you might think that alpha plus beta plus gamma squared will be this plus something plus this. Well, and that is probably what I'm gonna do right here. So let's do this. The thing is, how do I type alpha, beta, and gamma on the computer? This is out of question. I'll just write ABC, ABY, I guess. Okay, A plus B plus gamma squared will be equal to 3 squared, which is 9. Now, there is a squared, there is a well, why not let us do every single term one by one to show every step. A times A is A times B is AB, well, alpha beta plus alpha gamma plus beta squared plus beta gamma, and also beta alpha, nearly forgot about that thing, plus gamma alpha plus gamma beta plus gamma squared. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, and I've shown myself that I can calculate. Yeah, that's a joke, isn't it? Now we can see there is alpha squared plus beta squared plus gamma squared right here, these 3 terms. Then you have alpha beta and beta alpha, which is essentially 2 alpha beta. Then alpha gamma and gamma alpha, 2 alpha gamma, plus beta gamma and gamma beta, which is 2 beta gamma. And now we have essentially a value of squares, which we know is 13. So we go to 13 plus 2 times the alpha beta beta gamma alpha gamma term, which is equal to 9 because we didn't change anything yet, so everything is equal to 9. And now we rearrange this so that this big term is actually equal to 9 minus 13, which is minus 4, plus divide by 2, so it's minus 4 divided by 2, which is negative 2. So this term is negative 2, and let us look back onto this equation. A, B, C, this is term C, and for term C you don't need to do a negative, so it's just C over A equals negative 2, and A is 1, so C is negative 2, and also Q is negative 2. So yes, so we've got the answer for this question right here. Now question 6, this is the last of section A because this is going to be long if I don't cut it in half. Okay, a sequence defined by a1, 7 and ak plus 1 is equal to 7ak minus 3, and calculate the value of the third term. Now, this case, you just need to step through this equation 2 times, and so we've got 7 times a1 minus 3, which is 7 times 7. 7 times 7 minus 3. If I'm not mistaken, yes, I am right. So 7, this is term 2, T2 is that. And so it is 49 minus 3, and so it is 46. Next step is T3, which is equal to 46 times 7 minus 3, which is a giant's huge number. I'm not doing the mental math for that. I'm gonna type in my calculator. Do not do mental math in the exam if you want to avoid any careless mistakes. So here, this is the answer. 319 is term 3. Okay, so now that's 2 marks, which is typical. Now, proof by induction, the part that everyone loves, that an is this value. And now, here comes the problem is, you need to find a way of defining this term sequence as a factor or fraction. So now, actually, if you think about it, say that alpha 1 is this. So basically, every time you do anything with the number, you multiply it by 7, then subtract by 3. So, by induction, we need to find that for n equals 1, we need to show that n equals 1 is true from the first place. So, if n is 1, then the term of this big thing will be equal to 7. So let us try that out. 13 times 7 to the power n minus 1 plus 1 all over 2 is equal to 13 times 1, which is 13, plus 1 divided by 2, which is 14 divided by 2, which is 7. And here we have the first term solved, and yes, so that is the first step done. Then now we need to say that we assume that n equals k is true, and so the value t, sum of tk is equal to 13 times 7 to the power k minus 1 plus 1 divided by 2, and that is another term that we assume is true. You have to write also it is equal to the sum of, I think it's Okay, so now we need to write that because n equals k is true, we need to say that n equals, this is actually not a sum of, it's just a to the k is this term, and so we want to find a to the k plus 1 term, which we need to write that the ak term, which is 13 times 7 to the power k minus 1 plus 1 divided by 2, this whole thing has to be divided, well, multiplied by 7, then minus 3. Multiplied by 7 minus 3. So this is our every single step thing. So we add another step onto it, and here we have a bit more to do. Now we've got the k plus 1 term as this form, and now by proof by induction it gave us the answer, and we need to prove that this thing n plus 1 will be equal to 13 times 7 to the power n plus 1 minus 1 plus 1 over 2. It sounds easy, but it is not, and I am going to erase stuff. Do not do that in your paper because you need those marks. Now what you need to do right here is try to factorize stuff that makes it easier. And now, since you have a factor of 2, you can factor out a half out of the entire thing, and I'm using square bracket again. So because you factored half from this big thing, you have to remember that this whole thing is a single term, including the multiplied by 7. So this is essentially 13 times 7 to the power k minus 1 plus 1. Without the divide by 2 now, multiply that by 7, then minus 3 divided by half, which is 6. Now we've got this huge number, and actually I need to do a curly bracket, a normal bracket right here, square bracket go here. Yep. Okay, make sure the notations are right, if not you'll just mess yourself up. Now we expand stuff in, so again I'm omitting the half because I can't be bothered to type that in. Writing is way easier than typing, if you know. 13 times 7 to the power k minus 1 times 7, because we're expanding this bracket, we know that anything to the power n will, when multiplied by something of the base, you add 1 to the power. So this is essentially 13 to times 7 to the power k. Index law. So if you are not familiar with index law, I will suggest that you go and have a look. So now we have a plus 7 minus 6 divided by 2 because of this, and so plus 7 minus 6 is equal to plus 1. So 13 times 7 to the power k plus 1 divide by 2, and look, this might be the thing that we want. And to show the examiner, you write again, which this thing equals to 13 times 7 to the power of k minus 1 plus 1. Actually, plus 1 minus 1. And you could do this bracket thing, and this even shows that this term is 1 before you do anything with it. So this essentially have proven by induction that this equation thing work. So now down to remember, all these algebra step is only one mark, one single mark. All the other marks come from the steps of explanation. It's not a lot about the algebra. So the answer to this is that since n equals k is true, n equals k plus 1 will be true. Not since, if n equals k is true and equals k plus 1 will be true. Then next step, since n equals 1 is true, oh my god, since n equals 1 is true, we can say that n equals 1, 2, 3, 4 is true, and so does every natural numbers. So yes, and after you've written everything like this or similar to this, you can refer to mark schemes from past papers to find the best way you can put the conclusion in. And finally, to show that you're finished, QED is the last thing you want to put is essentially say this proof is done and finished, complete. So now we are done with section A, and now thank you very much for watching. If you have any question, you can feel free to give me a message. I will see you again on part B if you want. And if you did enjoy this, well, you won't, because it's a question paper. So if you think this helped, then feel free to subscribe or like. So now I will see you next time.